Hello guys, welcome, and in this video I'm gonna be showing you how to create this kind of snow simulation inside of Maya. And here's the final result, so take a look at this. It's not a very realistic simulation, but I think it can be used some sort of small animation project. Anyway, to create that, I'm gonna go to the FX tab first. And I'm going to use nParticles. So I want to start it by creating a new sphere polygonal mesh and bring it up a little bit. And also I'm going to create a plane for a ground and put whatever object you want. It's going to be a ground plane for a collider, so you can use whatever shape you want. So you can just combine these two, maybe a little bigger. Hit spacebar, and under the mesh you can see combine, and you can kill the history. Now we got a ground plane. I'm gonna make this as a passive collider, so you can go to enclose and create a passive collider with this object selected. So we got new nucleus and enrich it. That's good. And now I'm gonna fill this object with nParticles. So that's pretty simple. Select this object first, and you can go to nParticles menu, and there's a fill object, and click on checkbox, and you're going to see this option. You can see the resolution. If you increase the resolution, the amount of particles will be increased. So that's kind of simple. I'm going to go with 10. Let's try 12 first. And if you take a look at this, I guess that's quite much. So let's go with 12. I guess that's pretty nice. And now we can hide the sphere, because this is the only thing we need. And if you run the simulation now, it looks like the ground is really slippery and doesn't look like a snow simulation. It just looks more like some sort of water simulation there. So what I'm going to do is, first of all, select the ground plane. We can go to the enrich shape node under the attribute editor. So what we can do here is we can increase the friction to make it stop when it collides to the ground plane we created. So also there's a stickiness. I'm going to set it to 0.1. Let's check this out. Okay, and we can also do the same thing on the nParticle. So we can go to nParticle shape node in the attribute editors, and there's a collision setting, and you can turn on self collide. This can give you more realistic looking there, but also takes more time to simulate. And it looks like the particles are floating a little bit. To fix that, select the ground plane, and if you display the collision thickness is a little thicker than the actual mesh, so we can remove the thickness to prevent that kind of effect. So now we got a proper simulation. And also the particle itself has a collision thickness, so but don't worry about that. Now what we need to do now is to adjust the friction and stickiness. Let's focus on that. So let's increase friction to 0.8 and also we need stickiness. Let's go with 0.9, maybe 1. Trying to look for a best value. Now it's sticking to the surface a little better than before, or you can even increase it and see the result, and you can find the best value for your demanding simulation. And here's a simple tip, by the way. There's under the shading tab, you can change the particle render type in the viewport. Most of them is not going to work in Arnold in Maya, but it's really helpful to preview the results. So I'm going to use multi-points, for example. You can set the threshold. Doesn't really change anything, but and there's a count for this. You can increase it, and it looks more like a heavy simulation, but it only has 10,000 particles. Doesn't really changes the amount of particles, but it looks like it's a pretty heavy simulation there. So there's also point size setting. You can make it look more like a snow, and you can also use opacity for this thing, and you can also use lighting there. And if you run the simulation, maybe it look more like a snow. So we can always go back to the collision setting. So I'm gonna try to convert this particles into a polygonal mesh. So let's try this out. To do so, we can select our nParticle mesh and go to modify menu, and there's a convert tab, and we can click on that, and there's something called nParticles to polygons, so we can click on that. Now everything's gone, but don't worry about that. The nParticle shape node is still alive. So what we can do is we can go to output mesh menu in the particle shape node, and there's something called threshold. We can remove the threshold to see all the particles exported out to a polygonal mesh. So if you run the simulation, it looks like a really creamy liquid. So that's actually not a really desired result. So what we can do is we can reduce the blobby radius scale. We can adjust that. There's a lot of things you can do here. But if you see the wireframe, you can see the resolution is not very high. That's the reason why we're getting this kind of awful surface shading there. So what we can do is we can there is something for resolution and triangle size, but what determines the resolution is actually the triangle size, so we can reduce it. Now it looks a bit better, but you can see the meshes are a little smaller as the resolution grows. So what we can do, we can adjust the blobby radius scale to fill this up. So now it looks like it's got high resolution, but we see another problem here. The problem is that this mesh got an awful topology. You can see this kind of triangles all over the place. The triangle doesn't matter, but it's kind of messy there. So what we can do is we can change the mesh method to deal with this problem. So we can go to mesh method, and we can choose tetrahedra or acute tetrahedra. So I'm gonna go with acute tetrahedra first. And if you take a look at this, if you compare to this one, there's holes. So there's a lot of problems with this one. But with acute tetrahedra, most of those holes are gone, and it's got pretty better results. So if we turn off the wireframe override and take a look at this, looks a bit better. And if you run the simulation, you're gonna see the result. If you think your simulation is way too slow, you can reduce the resolution a little bit by increasing the mesh triangle size. So it's got low resolution now. It's got faster simulating speed. So now that's it. And you can always change the blobby radius scale to get better result. Yeah, I think it's got much better than before. So if you don't like the movements of the particles or everything or anything, you can always go to collisions and tweak the settings. There's a lot of things you can do. Not only frictions and stickiness, there's also a collide width scale and self-collide width scale, and this thing affects pretty much the result. So anyway, I think the simulation looks not so bad, so I'm gonna go ahead to create some materials for this node. So I'm gonna render this out with Arnold before we go. I'm just telling you. So before we make some materials for that snow, we can create a physical skylight under the Arnold menu, and just click on that. And if you go to the render view window for Arnold render, so let's scale it down, you're gonna see the render result. I think the light is not bright enough, so what we can do is select the physical sky and increase the intensity there. Now there's our mesh. We can see all the object in the scene in the render view. And if you don't like to see the sky and everything else in the final render view, here's a little trick there. You can go and select the physical sky, and under the visibility you can delete the camera visibility. So now it is not visible in the camera, but it's affecting the objects in the scene, such as specular and diffuse and everything. Also, you can tweak all of these values here, and you can also go to the viewport tab and remove the sky radius. What you get is you're not going to see the sky dome light object anymore in the viewport, but it is still functioning exactly the same as before. So that's a cool thing. So anyway, let's start to create new material for this snow object. So what I'm gonna do is let's create a new material by assigning new material on this object, and I'm gonna use a AI standard surface, which is new in Arnold 5. So let's click on that, and now we got that. And what I want to do is actually I like the color, but to add more detail on the surface, what I can do is actually we can go under the geometry tab and we can go to bump mapping and we can click on that, and you're gonna see multiple types of textures, but what I'm looking for is not really in here. It's actually under the Arnold texture tab. So I'm gonna use AI noise. If you can't find it, you can just search in the search bar here. Let's apply this, and you're gonna see this kind of thing, but that doesn't really matter. Just close it, and we can go to hyperjade. Here's the window. We can get the graph network, and we got the texture here. We can just drop this by dragging with the middle mouse, and what we can do is we can connect this into the bump value, but it's not gonna work. So what we can do, we can bring out our red channel and connect to that, and if you see in the render view, it's not affecting them much. So let's solo out the noise texture, and you can see its frequency is not that high, so let's increase the octaves and let's add more detail. Maybe distortion is not gonna help us out that much, but let's add a little bit, and also increase the linearity to get more detail like that. And you can also increase the scale. Let's go with 3, and mode to scholar. The advantage of using the AI noise is that even though your mesh is not correctly UV unwrapped, it is usable since it's using the object space, not the UV. So it's really useful when it comes to use some sort of dirty mesh. Let's increase the scale and let's see the overlooking, and it looks more like a more tough surface there. So, but I guess it's a little intense. So what we can do is, here's my hyperjade tab again. We can select our bump to the node, and always we can change the bump depth value there. I'm gonna do it in my attribute editor actually. So what I can do is reduce the value. I want it to be a little bit like that. Let's go with 0.2. Yeah, I guess around 0.1 is pretty nice. You can get your best value, best number to get a best result. So I think I like this, and you can look around how it looks like, and if you liked the final results, you can render this out. I'm gonna run the simulation to see how it looks like. Yeah, it looks not that bad. If you like more realistic and more accurate simulation, you can use more amount of particles by increasing the resolution when you fill the object. also you can tweak the values in collisions menu here. And if you like the result and you want to render out the final image sequence, you can go to render settings and you can set the file name, and choose your image format. And this is quite important if you want to render out multiple image sequence. So you can choose whatever type you want, and you can choose the frame padding. You can see how it goes here. If you set it to 5, that goes like that. And you can set the start and end frame. You can set it something like that, and you can set the by frame, and you can set the camera you want to render with. And you can set the resolution there. If you want a full HD, you can set like that, and also you can create a custom resolution for your own. And if you set the common settings up, you can go to render. You can set the samplings. If you want a best quality, you can go up to higher value, but it takes a lot of time. And clamping and filter is not that important. And there's ray depth, but it doesn't really matter in this case. And there's environment, it doesn't really matter. This is kind of legacy stuff. And motion blur is quite important to achieve more realistic looking, and lights and textures, subdivisions. I guess that's all you should take care of when you're rendering out. And to render out this sequence finally, you can set the project. Setting the project is quite important. If you don't, the file's not gonna be saved correctly, so that's quite important. And final step is you can batch render if you're using the non-student version of Maya. But if you're using a student version, it's not gonna allow you to batch render it with external renderer like Arnold. So what you can do is, there's a cool new function in Maya 2018 which is called a render sequence. So you can click on this one, which is highlighted in green box there, and that's gonna render out the whole frame you set it up. So that's a simple way to render out multiple frames. And if you're done, you can load it with any editing software you use, and that's it. Quite simple. So I'm not gonna render it out. Anyway, that was it. And if you have a better solution or idea, or have any questions, please leave a comment. And yeah, this